Okay, so chapter 11 is all about area, finding the area of something. Now you tell me, area, is that inside or is that outside?
Inside.
Area's inside. Just a little bit of a heads up for you guys, because area is something you've all seen before, it's a simpler topic, there will be more difficult questions asked on tests and quizzes. Just so you know, it won't be just so straightforward.
Like, is it worded?
Yeah, you'll see when we get to that point. But before we get there, let's just talk about what area is. Did you ever wonder why we always have, so if we're finding the area of like the floor, we always say, well, the area of the floor, say, is like 66 centimeters, then what do we say? Squared. Did you ever wonder why we do the squared, or does anybody know why we do the squared at the end?
Because it's technically 2 dimensions.
Good. Okay, so we say it's squared because it's 2 dimensions. What are we finding? We are basically asking how many 1 by 1 squares can fit a space. So if I'm trying to find out the area of this floor or the area of the ceiling, I'm literally asking myself how many 1 by 1 squares fit in that space. It's 2 dimensions. There has no depth, right? So how many 1 by 1 squares? Now, if it's inches, how many 1 by 1, inches, how many 1 by 1 square inches fit that space? That's why we say units squared. Okay, any closed region has an area. Now, do you think it would be smart to sit there, if I want to find the area of something, to sit there and count how many squares fill it? No. Not only would that take forever, but also it's not always working out perfectly, right? You might not get a full square. It might be a fractional part of a square. So what happened? The mathematicians came up with formulas. And that's what we're going to go through, some of the formulas today. So to find the area of a rectangle, I know you guys are usually used to writing length times width. Length times width is absolutely fine. If you want to write length times width, that's perfectly fine. Okay, in geometry, we step it up a little bit, and instead of length times width, we write base times height, which is the same. Max, could you take your AirPods out? Anybody else that has their AirPods in, please take it out. Now you tell me, a square. Is a square always, sometimes, or never a rectangle?
Always.
Always. A square is always a rectangle. So do you agree that since a square is always a rectangle, I can always use the formula for the rectangle on the square? Yeah, so since a square is always a rectangle, we're always allowed to use base times height to find the area of a square. But what do you know about the base and the height of the square? What do you know about all the sides of the square? Ben? They're equal. Aren't all the sides of a square equal? So wouldn't the base and the height be the same number? So instead of saying the area of a square is base times height, what we do is we take one side and we call that S, and then we square it, side squared. Okay, if 2 closed figures are congruent, then their areas are congruent. Okay, if 2 closed regions intersect only along a common boundary, then the area of their union is equal to the sum of their individual areas. What does this mean? Right, we all agree area is the inside, right? So let's say I gave you this weird shape, and I asked you to find the area of this weird shape. It sort of looks like 2 figures added together, right? Sort of put together. So what this postulate is telling us is, since we're finding the interior, if I find if I find the area of the pentagon and then I find the area of this quadrilateral, I can find their areas separately and then add the two areas together, and that's the area of the whole figure. Would that also work if I were finding the perimeter? Can I find the perimeter of the pentagon, then find the perimeter of the quadrilateral, and then just add those two perimeters up? No, why not? How come it works for area, but it doesn't work for perimeter? Oscar?
Because there's sides overlapping.
Good, because remember, the perimeter is just the outside. So this little segment in the middle, is it even in the perimeter at all? No, but when we divide and sort of conquer, wouldn't that segment be added not just once, but twice, when it shouldn't be added in at all? So the rules for perimeter and area are different. All right, let's do a sample problem. Given the area of the rectangle is 20 square meters, the altitude is 5 meters, find the length of the base. Now, some of you might be saying, well, why did you label the altitude here? Shouldn't this side be the altitude? It does not matter. Why? We know an altitude is made with right angles. It's the height. Do we all agree? And in a rectangle, all the angles are right angles. So right now, this looks like the height. But what happens if I rotate it? Wouldn't the 5 then look like the height? So that's why it doesn't matter. As long as the side's making the right angle, it is a height. It's some kind of height. So we are talking about the area of a rectangle. We know the area of a rectangle. I'm going to use base times height. But what have I done this time? I switched it up. It says the area is 20 square meters. So what does that mean? Where do I put that 20 in for? Good, we're putting the 20 in for A. So 20 is equal to, now they're saying the altitude is 5 meters. Do we all agree that's the height? The altitude is the height? Find the length of the base. So now I'm solving for B. If I'm going to solve for B, I need to get it all by itself. How should I get it by itself? Divide by 5. You got it. So then B will equal 4 meters. Is it 4 meters squared or 4 square meters? No, why not? Why am I just saying meters and not meters squared? Maya? Good, because it's not the area, it's the length of just one of its sides. All right, number 2, I'm not asking for area, I'm asking find the perimeter of a square whose diagonal is 10. So I'm going to draw my square, and I'm going to label my diagonal as 10. All right, I need to remember some properties of a square. Who remembers? What do we know about all the angles in a square? They are all not only congruent, they are right angles. And what do the diagonals do to the angles? They bisect them. So the 90 gets split into 45 and 45. So now I'm going to take one of these right triangles and I know I need to remember that opposite the 45s are x and x. Who remembers what's opposite the right angle? X root 2, you got it. So now we have to solve for x. When I go ahead and solve for x, my equation is going to be x root 2 is equal to 10. A lot of you still mess up this simple algebra. At this point, you divide by root 2. X equals 10 over root 2. Can I leave a radical in the denominator? No. Then we multiply top and bottom by root 2. So x will equal 10 root 2 over what? Whole number 2. Now we simplify the two whole numbers. 10 divided by 2 is 5. So one side of the square is 5 root 2, which means what for all the sides? They're all 5 root 2 because they're all congruent. Can we now find the perimeter? Yeah, the perimeter is going to be 20 root 2. All right, number 3, we're going to do it 2 different ways. Number 3, we're going to do it 2 different ways. It says find the area of this region. Clearly, there is no formula for this shape. So what are we going to do? We're going to split it into shapes that we can find the area of. There's 2 options here. One option is to draw lines and sort of create little mini rectangles. And then once I create mini rectangles, I find the area of each rectangle and then do what with all the areas? Add them. That's one way to do it. The other way you can do this is you can close this up here and here and find the area of the biggest rectangle here. Do we see that? But then subtract out these 2 areas. Does everybody understand both ways? I do not care which way you use. I will not tell you which way to use. It's whatever you prefer. We're going to do it both ways. So let's go back to the first way I said. Let's create mini rectangles here. So I'm drawing segments to close things off. So I will label this area 1, area 2, 3, and 4. And let's go ahead and find area 1. All right, well, in area 1, do we agree? The height is 6, the base is 2. All right, so we're going to have base times height, so area 1. I guess instead of writing 1, 2, it might confuse you. I'll write area 1, area 2, area 3, area whatever. Call this A1, A2, A3, A4, just so you don't think those are lengths. All right, so my base is 2, my height is 6, so area 1 is 12 units squared. All right, now let's move on to area 2. Okay, so now area 2, we want to be very careful. For area 2, my base is not 7. This 7 represents this whole base. Remember what was there before? Right. So any ideas on how I can find the base of just the green area? Vincent?
Subtract 7 from 2.
Good. Look at the yellow rectangle. Aren't opposite sides congruent in a rectangle? So if the top is 2, the bottom is 2, which means the base of the green rectangle has to be 5. All right, what about the height? What about the height? Good. Similar idea. In the yellow rectangle, aren't opposite sides congruent? So if the left side is 6, the right side is 6, which means this total height has to be 8. So area 2, I'm going to have, again, base times height. So area 2 is, what was it, 5 times 8. So area 2 is 40 units squared. All right, let's move on to area 3. Again, it's another rectangle, so it's base times height. And we know the base is 2. Someone tell me, how am I going to find the height for area 3, this pink area? Oscar?
8 minus 5.
You got it. In the green rectangle, opposite sides are congruent. So if the green rectangle has a height of 8, the left side is 8, the right side is 8. So in order to make that right side 8, this has to be 3. Is everyone following along with where I'm getting all these numbers? So we're going to have 2 times 3. So area 3 is equal to 6 units squared. All right, now last but not least, we are at area 4. I'll highlight that in purple. So area 4, again, it's a rectangle, so it's base times height. My base is 3. What is the height? Oops, where'd we go? What is the height? So 8. It's the same as the other one if you go all the way back to the green one. So it's 8 times 3, so area 4 is 24 units squared. So now the total area is equal to 12 plus 40 plus 6 plus 24. Did anybody add that all up for us?
82.
Is it 82? I don't know. Did everybody get 82? Yeah? All right, so we're 82 units squared. That U just means units. The U just means units. So that was one way to do this. Remember I told you we were going to do it another way? So finish copying it down because then I'm going to erase all my markings and do it the second way. Anybody still copying? Okay. So the alternative way of finding this area is to close it up. I'll call this area 1, area 2. And what we're going to do is we're going to say the total area is going to equal the area of the big rectangle minus area 1 minus area 2. Do we agree? Okay, so let's talk about this big rectangle. Area of the big rectangle is going to be base times height. So my base, highlighted in yellow, is this, and my height I will highlight in pink. So I have a 7 and a 3. Is my base 10? No, we're missing a portion right here, right? But isn't that a rectangle? So opposite sides are congruent. So if that top is 2, the bottom is also 2. So my total base is not 10. My total base is what? 12. So we are 12 times the height. The height is not 6, but opposite sides are congruent, so this is 2. What's our total height? 8. So we are 12 times 8. Which is 96. Then let's go ahead and find our area 1. Well, what's the area of that area 1? Highlighted in green. Anybody know what's that area 1? Yeah? Yeah, it's 2 times 2, which is 4, so I'm going to subtract 4 from that. And then what's our area 2? Oscar? 10. It's right here, purple. 5 times 2, which is 10. So we have 96 minus 14, which once again is going to be 82 units squared. Same answer both ways, right? As it should be. Can I go on to number 4? Okay. The ratio of the base to the height of a rectangle is 5 to 6. If the perimeter is 110, find the area. So we're talking about a rectangle, so the first thing I'm going to do is draw a rectangle. Now they're telling us the ratio of the base to the height is 5 to 6. That doesn't mean the base is 5 and the height is 6. The minute we take numbers out of a ratio, what do I need to put into them? An x. So the ratio is 5x to 6x. But in a rectangle what's wrong? Does not matter, because if you rotate that rectangle, it looks different anyway. All right, now what do we know about opposite sides of a rectangle? They are congruent. So if the bottom's 5x, the top is 5x. If the left side's 6x, the right side is 6x. So now they're saying the perimeter is 110. How does this help me? They're saying the perimeter is 110. Find the area. Tanya? Good. Before we can find the area, don't I need to solve for x? We're going to use that perimeter to solve for x. So we are going to have 6x plus 6x plus 5x plus 5x equals 110. So we're 12x plus 10x equals 110. We are 22x equals 110. Oh, not 115. What do we get? X is equal to 5. All right, now that we know x is equal to 5, I'm going to go back and plug in. So we're 10, 12, 12, 10. Oh, that's wrong. What am I doing? I plugged in a 2, not a 5. I'm sorry. Let's try this again. We are 30, 30, 25, 25. There we go. Sorry, Miss A's still sleeping. Can I now find the area? Absolutely. Area of a rectangle is base times height. So we have 25 times 30. Did anybody multiply this? Oscar?
750.
750 units squared.
Do we have to leave it, for example, on the task 7?
All right. A rectangular picture measures 12 centimeters by 30 centimeters. It is mounted in a frame 2 centimeters wide. Find the area of the frame. When I say find the area of the frame, basically I want the area of this shaded region. So when I say find the area of the frame, I want the area of this shaded region. All right, so general game plan. How am I going to find the area of just the shaded region? Well, do we all agree if I find the area of the big rectangle, that's going to be all of this, which is too big. And if I find the area of the small rectangle, it's just this, right? Which is too small. So what are we going to do? Area of the big rectangle minus the area of the small rectangle. And wouldn't that just leave us with the yellow shaded area? So this is our plan. Hey, I'm going to start off simple. Let's go for the area of the small rectangle. Oh, sorry guys, there should be arrows here. That 2 is not really representing properly. So there should be arrows like this Do you guys have those arrows on yours? Okay. That might have been confusing you. That's what those two should have had next to them, those little arrows. Livy, AirPods out. All right, area of the small rectangle. Let's start there because it's easier. So we are base times height. Well, we are 30 times 12. Anybody multiply this? Probably do it in your head.
360.
Yeah, 360. All right, easy peasy, small rectangle. Now, the bigger rectangle takes a little bit more thought because they don't have dimensions. But look. Do we all agree that's the base of the small rectangle? And to get from the small to the bigger one, aren't I adding 2 centimeters to the right? But if I'm adding 2 centimeters to the right, don't I also have to add 2 centimeters to the left because it's that same gap? So over here is also 2 centimeters. So what does that mean the total base of the big rectangle has to be? 34. 30 plus 2 is 34. Now we're going to do something very similar with the height. Now the height of the small rectangle, just highlighted it in green, is 12. But didn't I tell you there's 2 centimeters height here? And does that mean there's also 2 centimeters on top? So what does that mean our total height is going to be? 12 plus 2 plus 2, which is 16. Tell you how I got that. 34. 30 plus 2 equals 34. So then what are we going to do? We're going to do the area of the big rectangle, so base times height, which is going to be 34 times 16. 544? Thank you. So then what is the area of the frame? Anybody subtract those? I don't know. Oscar?
184.
Is that what you said, Sam? All right, 184 centimeters squared. So do you see what I mean now when I say the questions will be manipulated? It's not going to be like, oh, the base is 3, the height is 4, find the area. Questions are going to be manipulated. Yes, you may. All right, so that is the end of 11.1. Now let's move on to 11.2. Area of a parallelogram. The area of a parallelogram is going to be base times height, just like the formula for area of a rectangle. But how do we identify a height? A side is not the height. How do we identify a height? What must be there? Julia? Good, an altitude, a right angle. If you do not have a right angle, that is not your height. Like right now, the way I'm standing, the way I'm leaning, if somebody were to measure me, would it be an accurate height? No, because I'm leaning back. I would be shorter if they tried to measure me now. But when I make a right angle with the ground and now somebody tried to measure me, would this be an accurate height? Absolutely. You have to make a 90-degree angle with the ground if that's the height. All right, area of a triangle. To find the area of a triangle, it's going to be half base times height, or base times height divided by 2. It's the same thing. Half base times height or base times height divided by 2. It's all the same. All right, let's do some problems. All right, find the area of each triangle. The first problem I gave you is nice. Why? Why have I been nice in this problem?
You gave us the length and the base and the height.
I gave you the height, right? I gave you that right angle, so I know that 10 centimeters is the height. The height always connects to the base. So some students ask, well, how do you know which side the base is? The base is always the side the height connects to. So wherever that right angle meets, that side is then the base. And you don't want part of the base, you want the whole base. So area of a triangle is half base times height. My base is 15, my height is 10. I think I had explained this before, right? You don't have to multiply 15 and then 10 and then take half of it. What you can do is just take half of one of those numbers. What does that mean? 2 goes into 10 5 times. So then the area of this triangle is going to be 15 times 5, which is 75 centimeters squared. And if you did it the other way, you do 15 times 10 is 150. Half of 150 is 75. Either way, you get the same answer. Hey, I purposely wanted to show you letter B because do you see our triangle is only this yellow shaded area? That's the triangle. It's an obtuse triangle. The height of an obtuse triangle falls outside of the triangle. So that means this is the height. So our height is 8, but our base is not this whole thing. That's not the base. What's the only base here? 7. 7 is the only base there. So the area of the triangle is half base times height. So we are 7 times 8. Can I simplify just the half and the 8? Can I do that? Absolutely. Half of 8 is 4. So the area of the triangle is 28 centimeters squared. Oh, sorry, millimeters. Yes, Maya.
How does it solve for like when it goes outside of the triangle, how does that still solve for the obtuse one?
So it's telling you the height of that obtuse triangle. So they're saying this is that obtuse triangle. When it's tallest, it's going to be 8 millimeters. All right, now I'm switching things around. It says find the base of a triangle with an altitude of 15 and an area of 60. So key points here. They said triangle and area. I see triangle, I see area in the same problem. I immediately write down the area of a triangle formula. So area of a triangle is half the base times the height. But they're telling us the area is what? The area is 60. So where am I putting that 60 in for?
Area.
Good. 60 equals half. They said find the base. So my B stays. And they're saying the altitude is 15. Well, isn't an altitude the height? So it's half of 15. Half B times 15. Do you think it would be smart to take half of 15 and then get 7.5? Do you think that's going to be helpful to us? No, that's not going to be helpful to us. So what I need to do is I need to recognize that I need to isolate the base. So we have E equals half times B times 15. So I need to get B all by itself. We have a choice. Do you want to get rid of the half first or do you want to get rid of the 15 first? It doesn't matter. What do you guys want to get rid of first? The half? Okay. So I can cancel out this half by multiplying by 2 on both sides. So that cancels that out. So now I'm going to have 120 is equal to B times 15. How do I get rid of that 15? Divide by 15. You got it. Did anybody divide this? What'd we get? 8. Thanks. So we are 8 units long for the base. Yes.
So you multiplied because you couldn't divide.
So, well, dividing by a half is the same as multiplying by 2. So let's say you had 60 equals a half times b times 15. And you said, okay, well, I'm going to divide the half, right? That would cancel there. And then you divide the half here. But that would be 60 divided by a half. Keep, change, flip. So I essentially did divide by half, but I just shortcutted it and showed that I was multiplying by 2. So that's where we got the 120 equals b times 15. And then we divided by 15. See that? Okay. Find the area of a parallelogram whose sides are 14 and 6 and whose acute angle is 60. I need to draw a parallelogram. Sure. Try this again. Okay, so find the area of a parallelogram whose sides are 14 and 6. It does not matter which side you say is 14 and which side you say is 6. So I will say 14 is here, 6 is here. It does not matter. All right, and then it says whose acute angle is 60 degrees. I am very strategically going to put my 60 degrees in this corner. And now we want to find the area. So we need to remember area. Oh, guys, by the way, if you see this drawn like that in your textbook, that means parallelogram. That little four-sided shape, they mean parallelogram every time. So area of a parallelogram is base times height. Do I have a height? How come 6 is not my height? How come 6 is not my height? Only 2 people can answer this. That's not good. How come 6 is not my height? Better. Alexios? Because it's a diagonal?
Or like, not like straight up.
Good, it's slanted. Yeah, it's not making a right angle. The height has to make a right angle. So what do I have to draw here? I need to draw an altitude. I'm very strategically going to draw my altitude here. Why? Why have I chosen to draw my altitude there, Simon?
It forms a 30, 60, 90 triangle.
Because it forms a 30, 60, 90 triangle. And didn't I say the base always connects to the altitude? So that means this side right here is my base. Do I have a length for that side? Yeah, remember in a parallelogram, opposite sides are congruent. So if the top is 14, the bottom is also 14. So the area of this parallelogram has a base of 14. Now I need to find the height. I'm going to use the 30, 60, 90 triangle to find my height. Opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. Do we agree 2x is equal to 6? Therefore, x is equal to 3. So that means this side is 3. And what is my altitude? 3 root 3. So the area of this parallelogram is 14 times 3 root 3, which is going to be 42 root 3 units squared. It's like nothing ever goes away, right? Like, I thought we were done with those 30, 60, 90s, and 45, 45. Nothing ever goes away. It all just builds. Alrighty. Find the area of an isosceles triangle with sides 10, 10, and 16. So what should I draw? An isosceles triangle. What do we know about an isosceles triangle?
The leg congruent.
Good, the legs are congruent. So shouldn't those be the 10s? And then they're saying the base is 16. Area of a triangle is half base times height. Is my height 10? Is the height here 10? Why no? Mia? Good, it's not making a right angle. So what do I have to do? I must draw an altitude. And when I draw down that altitude from the vertex, what happens to that 16? Guys, I don't know if you realize this. This is a triple times 2. What's the missing side? Good. This is a 3, 4, 5 times 2. It's a 6, 8, 10. Nothing's going away. Area of a triangle is half. The base is 16. The height is 6. I'm going to do half of 16 is 8. So the area of the triangle is 48 units squared. All right, 2 more questions and then we are done for today. A triangle has the same area as a 6 by 8 rectangle. Stop. A triangle has the same area as a 6 by 8 rectangle. What should I draw? A rectangle and a triangle. So I'm going to draw a right triangle. And I'm going to draw a rectangle. And we know area triangle is equal to area rectangle. And it says a triangle has the same area as a 6 by 8 rectangle. So I'm going to label this 6 by 8. Then they're saying the base of the triangle is 8. So this is 8. Find the altitude. So I'm finding x. Everybody okay with how I've set up my diagrams? All right, go back. The area of a triangle is the same area as a 6 by 8 rectangle. Where do you think I should start? Maya? Exactly. We are going to find the area of the rectangle since they're the same. The area of a rectangle is base times height. So the area of this rectangle is 6 times 8, which is 48. So now we want to find the altitude of the triangle, but it has the same area as the rectangle. So area of the triangle is half base times height. What do you think I'm going to put in for that area of the triangle? For a triangle, what number do you think I'm going to write there? What number am I going to write for area of triangle, a triangle? What number am I going to put there? 48. Yeah, we're going to put 48. And that's going to equal half. The base is 8. Our height is x. So I'm going to simplify this. Half of 8 is 4. So now we have 48 equals 4x. So what does x equal? 12. Is that my height? Yes. If at any point I'm losing you or you don't understand why I did something or how I got something, you need to stop me because it just snowballs. So if you don't understand it now, it's just going to get worse. We're good? All right, final problem. Find the area of an equilateral triangle with a perimeter of 30. So I'm going to go ahead. I'm going to draw my triangle. If the perimeter is 30, what does that mean for each side since it's equilateral? 10, 10, and 10. and the area of a triangle is half the base times the height. What's the problem here? Max?
It's not a right triangle.
It's not a right triangle. What must I draw? An altitude. And when I draw that altitude, what happens to the 10? Splits to 5 and 5. I can do the Pythagorean theorem to find the height, absolutely. Or I can remember that an equilateral triangle is also what? Equilateral triangle is also, anybody know? Equiangular. What does that mean? An equilateral triangle is also equiangular. All the angles are congruent. So if I have a triangle with all three angles congruent, what does that mean? It's going to be 180 divided by 3, which is 60. All these angles are 60 degrees. What does that mean for the top by the altitude? What has happened to that angle? Splits to 30s. So, in my opinion, this is a lot easier than doing the Pythagorean theorem. So, opposite the 30 is x, so I could just redraw this triangle. So, opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. So x is equal to 5, which means the height is 5 root 3. So now we're going to have the area of the triangle is going to be half. Is my base 5? Is the base 5? No, what's the base? 10. It's the full base times the height, which is 5 root 3. I'm going to take half of 10, which is 5. So the area of the triangle is 25 root 3 meters squared. Alrighty guys, no homework for tonight. Happy end